Today in this class we are going to discuss about data dictionary and database buffer. In the last class we had a discussion about file organization and we have seen sequential file organization and multi-table clustering file organization, right? So today we'll be discussing data dictionary and database buffer. So to begin with, let us see how the data dictionary is being stored in our database. So first let us try to understand what we mean by data dictionary. Data dictionary is also called as system catalog, right? And this data dictionary stores the metadata. So you must be knowing what is metadata. Metadata in general is the data about data, right? So data dictionary is actually storing the data about the data that we are actually storing in a database. For example, the data dictionary is storing the information about relations. It is storing the user and account information, including passwords. It is also storing statistical and descriptive data, physical file organization information, information about the indices those are being used. So all this information or similar information which is narrating something about the actual data that is being stored in the database, it's stored in this data dictionary. So all these different forms of data are metadata, right? So this metadata is stored in data dictionary or system catalog. Now let us see one by one. So what we are storing under information about relations. See, we know that in our database schema we are having multiple relations, right? And every relation is having attributes. Every attribute is described with some type, right? Similarly, we are having some integrity constraints, those are being imposed. Like what is the primary key of the relation, what are the foreign keys in the relation, likewise, right? So all this information about the relations, is being stored in data dictionary. Say for example, we are storing names of relation and its attributes, names and types of attributes of each relation, names and definitions of views, integrity constraints. So we are creating the views also in the database schema. So whatever views are being defined, the definitions of those views need to be maintained, the names of the views need to be maintained. So all this information is being stored, right, in data dictionary. Now next, user and accounting information is being stored, including the passwords. So as we know, for database management system we are having multiple users, right? And these users are actually having different roles. They need to be authenticated, right? So for this authentication they need to provide with some passwords, right? Also there is a need sometimes to maintain the accounting information for how much time the users are using the system, right? So all this kind of information is also being stored in data dictionary. Further, the statistical and descriptive data. So under statistical and descriptive data, the number of tuples in each relation are being stored. The method of storage for each relation, how the relation is being stored, that information is also being stored. Also the number of tuples in every relation, that statistics also need to be stored. Okay. Further, under physical file organization information, we may have such kind of information. How the relation is stored, so whether to store the relation, whether the sequential file organization is used, whether hashing is used, whether heap structure is used to store the data or to store the relation. So that kind of information is being stored in data dictionary. Further, the physical location of relation, meaning as you know the database schema is being stored, right, but underlying that database schema we are having certain operating system files, those are being allocated. So what is the actual operating system file name? What is the disk address of blocks containing the records of the relation? All that physical file organization information is also stored in data dictionary. Further information about indices. So we are going to discuss about indices in this unit later. But let me tell you, the index is a structure that is being used to expedite the access to data, right? So we are creating the indices on respective attributes for certain relations. So all this information about the indices also need to be stored, and that too is being stored in data dictionary. Now let us see how actually this data dictionary is being stored. So this data dictionary or catalog structure can use either the specialized data structures and code, or it may also use a set of relations with existing system features used to ensure efficient access, right? So usually this alternative, that means the set of relations, catalog structure in the form of set of relations, is being preferred to store or maintain this data dictionary. So a possible catalog representation may look like this. As I stated earlier, we want to store information about relation. So in relation metadata table, we are storing relation name as one attribute, which is the primary key. Why relation name is the primary key? Because in a particular database schema, it is not allowed that two relations are having the same name. So for this particular relation metadata, relation name is the primary key. Along with this relation name, we are storing number of attributes, storage organization, location of that relation, and so on. Now every relation is having the attributes, so we are storing attribute metadata. So in attribute metadata, we are having attribute name along with relation name as the primary key. So this is the composite primary key, right? So why we are having attribute name, relation name as the primary key? As I stated, relation name is unique, but attribute name may not be unique throughout the relations. For every relation, we are having unique attribute names. So meaning, for a particular relation, we cannot have two attributes with same name. But across the relations, we are having similar attribute names, right? So for this attribute metadata, we are having this primary key as attribute name, relation name. Also, we are having other attributes like domain type, position, length, and so on. So this is about attribute metadata. Similarly, we are having user metadata with the attributes username, encrypted password, group, and so on. We are having index metadata, that is storing index name, relation name, index type, index attributes, and so on. We are having view metadata, which stores view name along with the definition. So these are only few examples of metadata. We are having lots of such metadata information to be stored in data dictionary, and we are making use of such kind of relations to store that data. So see here, the relation schema representing this system metadata. So see here, in the similar way how we represent the relational schema, we have represented this metadata tables also in the form of relational schema. So we are having relation metadata, we are having attribute metadata, index metadata, view metadata, user metadata. So these three relations, relation metadata, attribute metadata and index metadata are related. Meaning we are having this relation name which is primary key of relation metadata, that is used as foreign key in attribute metadata, and this relation name is also used as the foreign key in index metadata, and that is why we are having depicted here the respective arrows, right, to denote that the foreign key or integrity constraints are imposed on respective relations, right. So this is the way how actually the relations are being stored, or the metadata or the data dictionary is being stored in the form of set of relations, right. So I hope you must have understood this concept. In database systems, whenever any data is being referenced or accessed, initially the data dictionary is being used. So data dictionary actually guides access of different relations, attributes, views and so on. So every information related to the actual database is being stored in our data dictionary, right. So I hope you must have understood this concept. Now let us proceed to the discussion related to database buffer. Actually, the concept of buffer may not be new for you. You must have learned this concept of buffer in operating systems. So we are going to discuss the similar concept of buffer with respect to the database systems. A major goal of the database system is to minimize the number of block transfers between the disk and memory. So this is the major goal of the database system. So we do not want much more block transfers between the disk and memory, because you might be knowing that the I/O operations and the block transfers are really very expensive tasks. So we do not want to have more number of block transfers between the disk and the memory. One way to reduce the number of disk accesses is to keep as many blocks as possible in main memory. So if we are storing lots of data, all the tables from the database in main memory, then we need not have such kind of block transfers, right. So one solution is keep as many blocks as possible in main memory. But as you might be knowing, the main memory that we have is limited in size, right, and actually the database size is too big, right. So it is not possible that we can accommodate maximum data from our database into the main memory. So at a time it is not possible to accommodate data from database or all the data from database in main memory, right. So as we cannot accommodate maximum data in main memory because of limited size of main memory, the goal is to maximize the chance that when a block is accessed, it is already in main memory, and thus no disk access is required. So, as I stated, since it is not possible to keep all blocks in main memory, we need to manage the allocation of the space available in main memory for storage of blocks. The buffer is that part of main memory available for storage of copies of disk blocks. So, let me repeat once again. The buffer is that part of main memory which is available for storing the copies of the disk block. There is always a copy kept on disk of every block, but the copy on disk may be a version of the block older than the version in the buffer. The subsystem responsible for the allocation of buffer space is called as buffer manager. Right? So buffer manager is actually responsible for allocating the buffer space and manipulating it. Right? So let us see now more details about buffer manager. So programs call on the buffer manager when they need a block from disk. Say for example, we are having the application program, right? So this application program suppose wants some block or some data from memory. So this application block actually sends the request to the buffer manager. So this BM is the buffer manager. So whenever application program requires some data from disk or block, then this application program sends the request to buffer manager. Right? Now, buffer manager will provide the address of the block in main memory to the requesting program. Now, buffer manager actually consults with the buffer area. So buffer area is the main memory. So buffer manager consults the buffer area. So if the block is already there in the buffer area, the requesting program is given the address of the block that is in main memory. So whatever application program is asking for, right, if that block is present in the buffer, then address of that block in main memory is being provided to the application program who is requesting it. But if the block is not available in the buffer, then the buffer manager allocates space in buffer for the block. So if the block which is requested is not available in buffer, the buffer manager will allocate the space in the buffer for that particular block. If there is no room in the buffer to accommodate the new requested block, then maybe the buffer manager will replace or throw out some other block from buffer to the disk to make the room for new block that has been requested by the application program. The block that is thrown out is written to the disk only if it was modified since the most recent time that it was written to or fetched from the disk. So if the block present in the buffer is not been updated or modified. Since it has been fetched from the disk, the block that is thrown out is not written back to the disk. So only if the block is modified, then this block is written back to the disk. Right? Now, once the space is allocated in buffer, the buffer manager reads the block from the disk to the buffer and passes the address of the block in main memory to the requester. So in any of the cases, now there is a space in buffer. So once the space is allocated in the buffer manager reads the block from the disk to the buffer and passes the address of the block in main memory to the requesting program. So this is how actually the buffer manager is working. These tasks in fact are similar to that of the tasks of buffer manager that you must have studied in operating system. Right? Now, let us see whenever the buffer wants to manage the buffer area, the memory management schemes need to be adopted by this buffer manager. So the buffer manager of database system uses the sophisticated memory management schemes. These schemes include buffer replacement strategy, pinned blocks, and forced output of blocks. In buffer management strategy, when there is no room left in the buffer, a block must be removed from the buffer before a new block can be read in. So, if there is no space available in buffer, then the buffer replacement strategy need to be used. What about pinned blocks? For the database system to be able to recover from crashes. So database recovery is being discussed in unit number 6. Right now we are only mentioning that this concept of pinned blocks is important with respect to database recovery. Right? So, for the database systems to be able to recover from the crashes, it is necessary to have some actions as far as the data blocks in memory are considered. For instance, most recovery systems require that a block should not be written to the disk while an update on the block is in progress. So, the block which is being updated is set to be pinned. The block which is being updated by the application program is set to be pinned. And if such a block is pinned, then that block is not allowed to send to the disk. Right? And the third strategy is the forced output of blocks. So there are certain situations in which it is necessary to write back the block to the disk. So even though the buffer space that the block occupies is not actually required, it is not needed, then also sometimes it needs to be sent to the disk. So this write is called the forced output of the block. So we'll be focusing upon all those schemes in detail in next class. So let's conclude today. Thank you.